In this video, we're going to be doing lesson 1.3, which is on geometric sequences. So last video was arithmetic, now we're on geometric. And a geometric sequence is a sequence that multiplies. So arithmetic added, geometric multiplies by the same number each time. And in a geometric sequence, we have a common ratio, not a common difference. We have a common ratio, and it's the number being multiplied. And it can be a fraction. It can also be negative. And if we're going to find this, we're going to take any term divided by the previous term. So any term, now in an arithmetic sequence, we subtracted. In a geometric, we're going to divide. So just like before, when we're checking to see if it's geometric, we need to check all of the numbers. Okay. So let's start with number 1. 12 divided by 6. 24 divided by 12. And 48 divided by 24. Every time I do that, I get 2. So yes, it's geometric, and my ratio is 2. Number 2, 270 divided by 810. We don't need to convert to a fraction until we're sure that it's geometric. So 90 divided by 270, 30 divided by 90. So every time I'm getting the same number. And it's best to write it as a fraction. So, well, yes, it is geometric. But to convert it to a fraction, if you don't know what 0.3 repeating is, if you go to math, enter. It's 1/3. Okay. Number 3, 10 divided by -2. -50 divided by 10. And 250 divided by -50. We get the same number every time, so that means it's yes. And r equals -5. Number 4, 8 divided by 4, 20 divided by 8, 60 divided by 20. So we're not getting the same number every time. So this one is no. All right, pause the video and try numbers 5 and 6. So number 5, you should have got yes with r equal to -1/4. And number 6, you should have got yes with r equal to 2.5 or 5/2. If it's a decimal that stops, it's okay to leave it as a decimal. Up here, you would have got 0.333333. So that one needed to be a fraction. This one you could have done -0.25. either one. All right, just like arithmetic, geometric sequences have their own formula, but this one is a little bit better, a little bit easier, because you don't have to simplify anything. So with arithmetic in advanced algebra 2, you had to do some extra work. You don't have that with geometric. So it's AN equals A1 times R, and then in the exponent is n minus 1. So A1, remember, is your first term. R is your common ratio. So number 7, we're first going to write a rule. Remember, when we write a rule or we write an equation, we don't plug anything in for n to start. The time when we plug in for n is when we're actually finding a specific term. So AN equals, my A1 is 1 times my R. So you can tell what your R is just by looking, but in case you can't, let's just take any term divided by the 1 before it, and we get 5. I want you to get in the habit of always putting that in parentheses, because if your R is negative and you don't do parentheses, you'll get the wrong answer. So it's better just to do it always. And then n minus 1. Okay. And that is our rule, our formula. That formula will let us find any term that we want. So let's find the 7th term. You'll notice that with geometric sequences, your numbers get pretty big. Oops, you can't see that. So we're going to type this into the calculator. And we get 15,625. Number 8. Find the formula. So my A1 is 130. My R, 65 divided by 130 is 0.5, 0.5. So you can put 1/2 or you can just put 0.5 to the n minus 1. And the 6th term is 4.0625. And then number 9, pause the video and try this one on your own. So you should have got 2 times negative 4 to the n minus 1. And your 8th term Should have got negative 32,768. And there's 3 more questions just like this. So why don't you work on questions 10, 11, and 12. So number 10, your AN, you should have got 8 times 3 to the n minus 1 power. And the 6th term is 1,944. Number 11, your R was 2/3. You did not need to put 0.6 or 0.67. If it's not a decimal that stops, it needs to be a fraction. And your A7, just plugging in a 7 there, gave you 320 over 27. And then 12, you got negative 1/4 for your R. So that's what your formula looked like. And then the 6th term, you should have got 25 over 8. Okay. Now we're going to move on to some questions where there's a missing term. And it could be a little bit more complicated with the geometric, but you still just kind of have a pattern or just a specific step that you do. You just have to remember that. So if this is my A1, this would be A2, this would be A3. Yeah, you could guess and check. If you forget the process, at least try, just guess some numbers. And remember, this is geometric, so we're multiplying. So it's a little different. But the actual way you do it is kind of weird. So we're going to find a root, not necessarily the square root. So under this radical symbol, we're going to take 100 divided by 4, 100 over 4, or you could just do 100 divided by 4. And then the root is going to be 3 minus 1. This is going to give us our R. So you may want to write down the steps. If we go to math and number 5, that lets us do any root. Oh my goodness, I keep forgetting. Math number 5. That lets us do any root that we want. So we're going to do 3 minus 1. And then under the radical, 100 divided by 4. And that tells me that my R is 5. So we're multiplying by 5 every time. So 4 times 5 is 20, times 5 is 100. So number 14, to find my R, let's see, this would be my A1, A2, A3, A4. Under the radical is going to be 13.5 over 4. And then the actual root that it is going to be 4 minus 1. So it's really going to be the third root. So we go to math number 5. It tells us that R is 1.5. You probably wouldn't have figured this one out by guessing and checking. So 4 times 1.5 is 6 times 1.5 is 9. So try number 15 on your own. So this would have been your A1, 2, 3, 4. This would have been your A5. And again, you could use any. I could have used A7 and A11. That wouldn't have mattered. So the root, it's going to be a 5 minus 1. So it's going to be a fourth root, 5 minus 1. And then we have 1250 over 2. And this one also had a common ratio of 5. So 2 times 5 is 10, times 5 is 50, times 5 is 250. All right. And then the last ones, it's giving us something to find, and these are not all the same. So like number 16, we're finding A1, 17, we're finding A3. So the process we take is just a little bit different for each one. So let's think back to our formula. Okay, that's kind of always our starting point. So we're finding A1. We have the R, and we do have a term. So if I let this be my AN, that means N equals 8. We're going to need to use this to find my A1. So in the formula, AN, well, that's going to be this 114,688 equals my A1. I don't know that. My R is 4, and my N minus 1 would be 8 minus 1. Because remember the little number, that's your N. So I need to figure out what this number is. That would be 4 to the 8 minus 1. Or you could just type in 4 to the 7th. And then these are just being multiplied, so I'm just going to divide. And we get 7. All right, so here we have A1. We have a random term. And we're finding A3. So you see all of these numbers are really close together. You could just set it up like number 13. Like we could do 13, because that's my A1. I don't know 2, don't know 3, but I know that A4 is 4,459. You could do it that way. I think that's the easiest way to do it. You could also, well, you would have to find the ratio. We're going to have to find the R regardless using this method. So you could find the ratio. You've got A1. And you could use, well, I don't know, that might be easier. We'll do this one this way, and then we'll see. All right, so if we do it this way, actually, I take that back. I don't want to do it that way. You could. If you like this method, go for it. But let's just use the formula. Okay. We got to find R. Either way we do it. So to find the R, we're going to use this root of, we'll take 4,459 divided by 13, and it's the 4 minus 1 root. So when we type that in, we get 7. So my R is 7. Okay. So AN, we don't really want to use A1. We can let this be our AN. So 4,459 equals A1 is 13 times my R is 7. No, I messed up again. All right, number 17. We've got A1. We've got a random term. We're finding A3. What we don't have in the formula that we need is the R. So let's start out by finding the R like we did up here. Okay. So my common ratio, we're going to take 4,459 divided by 13 under the root. Now this is going to be, the root that we're going to use is going to be the third root, because 4 minus 1 is 3. So if you type this into your calculator, you're going to get 7. So we're finding A3. So now we've got A1, we've got R, then I can plug in a 3 for N. So A3 is 13 times my R of 7 to the 3 minus 1 power. Oops. And we get 637. Okay. Number 18, we have the second term, the fifth term, and we're finding A4. So this one, if we look at our formula, we're really missing two things. We don't know A1, we don't know R. There are a few different ways that we could go about this. We could kind of do like what we did here, but with an extra step. So we basically would combine these two problems. That's going to be a little bit longer of a way to do it. We could turn this problem into one just like up here. Okay, so if we have, let's see, we start at A2, A3, A4, A5. So we know A2 is 6. We don't know 3 or 4. We know A5 is 0.048. This looks just like number 14. So let's solve it that way. So we got to find our R first. 0.048 divided by 6. And then it's going to be 5 minus 2. And you should get 0.2 for your R. So if we start at 6 and we multiply by 0.2, we get 1.2. Multiply by 0.2, we get 0.24. And so A4 is 0.24. This works well if your terms that you're given are really close together. If it was two terms like way apart, we'd probably need to work it out a little bit different. If you have any questions, let me know. Have a great day.